Hi, boys and girls. Today you're going to do lesson 9-3, which is using multiplication to divide. Okay, so essentially you're going to be taking a whole number, say like the number 2, and dividing it by a fraction. Okay, but we're not really going to divide, we're really going to multiply. And we're going to use this little trick called keep, change, flip, if you remember. So I'm going to keep this first number, I'm going to change this sign, and I'm going to flip this fraction. So I'm going to go through this. I'm going to keep this number, but because this is going to become multiplication, okay, and we can't really, if this becomes multiplication, we never really have a whole number times a fraction. The whole number has to look like a fraction. So I'm going to keep the 2 and put it over 1, because we know 2 over 1 is the same as 2 from previous lessons. I'm going to change this division sign to a multiplication sign, and I'm going to flip this fraction to its inverse. So instead of having 1 over 3, I'm going to flip it to its inverse, which is 3 over 1, which we know is the same as 3. And now we basically have a fraction times a fraction, and fractions times fractions, they play nicely together, so we can multiply. Just going to multiply the numerators. 2 times 3 is 6, over, multiplying the denominators across, 1 times 1 is 1. 6 over 1 is an improper fraction, but we know 2 over 1 is the same as 2, and 3 over 1 is the same as 3, so 6 over 1 is 6. But just to prove it, we're going to divide it out. If this is an improper fraction, I'm going to divide my denominator into my numerator, So 1 goes into 6 times, multiply it back, 6 times 1 is 6. So my answer here is 6. I'm also going to show it to you as an algorithm. Just showed you the algorithm. I'm going to show it to you as a model. So let's say I had 2 candy bars. Okay, 2 candy bars. Well, I'm going to cut them into thirds. All right, so that means putting 2 lines to make thirds. Okay, so I'm going to cut them into thirds, or 3 pieces. I got 1, 2, 3 here. Second candy bar, put 2 lines to make thirds. And then when I add up how many pieces I now have, if I took 2 candy bars and cut them into thirds, or 3 pieces, I have 1, 2, 3, 4, 5, 6. So my answer works out whether I'm using the algorithm or whether I'm using a model. Let's try another one. So let's try 3, whole number 3 divided by the fraction 1/4. So again, I'm going to practice this little, let me just fix this a little bit. I'm going to practice this little trick that I use. Okay? Again, keep, change, flip. All right? I'll even write it here. Keep, change, flip. So I'm going to keep this 3. I'll bring it down here. But again, it's got to look like a fraction, because this is going to eventually change from a division sign to a multiplication sign. And if I want to multiply fractions, they have to both be in fraction form. I can't really do a whole number times a fraction. So I'm going to take the 3, put it over 1. I'm going to change this sign from division to multiplication. And I'm going to flip this fraction to its inverse. So instead of having 1 over 4, I'm going to flip it to 4 over 1. Now I have a fraction times a fraction. I'm going to just multiply my numerators, or my top numbers. 3 times 4, I get 12. Over 1 times 1 is 1. This is an improper fraction that I can't leave, so I've got to divide 1 into 12. 1 goes into 12 times, and I'll multiply it back. 12 times 1 is 12. But again, just like 3 over 1 is equal to 3, and 4 over 1 would be 4, 12 over 1 without even, doing it out with division, I know it's equal to 12. Let me draw a little model to go with this. So let's say I had 3 pizzas. Okay, there's my 3 pizzas. I'm cutting them into fourths. That means I'm cutting them into 4 parts. Okay, so there I am cutting. So now if I count up all my pieces, if I have 3 pizzas each cut into 4 pieces, how many pieces do I have altogether? What is 1/4 of 3? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. So my model matches the answer to my algorithm. Let's try another one. I could do 5 divided by a half. Again, I'm basically doing a whole number divided by a fraction. And notice these are all unit fractions where, what do we mean by unit fraction? Where the numerator is 1. So again, I'm going to practice this little trick of mine, keep, change, flip. I'm going to keep the 5, but put it over 1 so it looks like a fraction. Change the sign from division to multiplication. And I'm going to flip this 1/2 to its inverse, which is 2 over 1. Then I'm just going to multiply my numerators, or the top numbers of my fractions. 5 times 2 is 10. Over 1 times 1 is 1. 10 over 1, we know just like 5 over 1 is equal to 5. 10 over 1 is really equal to 10. But just to prove it, again, 1 goes into 10 times, because 10 times 1 is 10. Again, I could do this as a model. So again, let's say I had, again, back to those candy bars. I have 5 of them. Squeeze one in here. Okay. And again, let me fix this one because they should really always all be about the same size. Okay. And if I cut them all in halves, meaning into 2 parts, I should end up with 10 pieces altogether. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my model is matching my answer to my algorithm. And let's do one more. Okay, lastly, let's say I had 6 divided by 1/5. Again, I'm going to practice keep, change, flip. I'm going to keep this 6, but bring it down and put it over 1. I'm going to change the sign from division to multiplication, because multiplication is the inverse of division. And I'm going to flip this fraction from 1 over 5 to 5 over 1. Now I've got 2 fractions here. Okay, they can play nicely together and multiply by each other. Again, I'm going to multiply the numerators first. 6 times 5 is 30. Now my denominators, 1 times 1 is 1. It's an improper fraction. I can't leave it, so 1 goes into 30 times, because 30 times 1 is 30. Okay, and if I was to make a model of this, again, let's say I had, 6 pizzas. I'll do candy bars again. A little hard to make fifths with circles. Okay, so let's say I have 1, 2, 3. I make these a little neater, sorry. 4, 5, 6. And I'm cutting them into fifths. So again, if I'm making fifths, I've got to have 4 lines. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. Okay. So every one of these has been cut into fifths. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. So if I have 6 candy bars and they're each cut into fifths, then how many pieces do I have altogether? 5, 10, 15, 20, 25, 30. So again, my model is matching the answer to my algorithm. All right. I hope this helps. Today, I know you're going to get questions where they are going to ask you to solve the algorithm, but they might also ask you to pick the model that matches the algorithm or matches the answer to the algorithm. So hopefully this modeling also helped you. All right, good luck with today's questions, and I hope you have a great day. Bye.